Good morning, everyone. Good morning, everyone. Today we are going to discuss a topic of multithreading. Till that we are discussing. Till that we are discussing a topics of oops and the exception handling. Today we are going to discuss a new topic. This is a important one. Why? Because when you are dealing with the real world projects, multithreading is the major concept. You have to be work some tasks parallelly. Normally, what is the multithreading means? Before understanding of a multithreading, you have to understand some terms. The terms are first process, thread, task. Okay, there are the three things we have. Normally, your computer also or your laptop also working on a same multithreading concept and multiprocessing concept. Okay, process is nothing but, suppose if you observe here in my bottom taskbar, I am opening one OBS Studio for recording and one notepad, and it is a Cloud AI and it is Chrome. It is VS Code I am opening, right? And Teams. These all are one process. OBS Studio is one process, Notepad is one process, Cloud AI is one process, VS Code is one process, Teams is one process. These are all the processes. Process have different environment and a different, that means each process have the separate environment, separate memory resources, separate what are the requirements it has. If you observe, if you go with a task manager, your system task manager, you can observe the how many processes your system can be run at a time and how many threads it will be run. I think in the performance, right. Here if you observe, currently my active processes are 247, my current threads are 2990. It will be varies. Why? Because some of the threads will be the vanish automatically. That means thread, what the process of thread is, a thread is helps to execution of a task. Thread is helps to execution of a task. So when the task is completed, it will be vanishes. If a new task can be created, a new thread will be created. So thread count is not fixed anytime, any moment. In a milliseconds of time, your new threads will be created, existing thread will be vanishes. So we are not confirmed that there will be a fixed count of threads and also a fixed count of processes in your CPU. Why? Because it will be depends on your CPU task. Here I have running the multiple process. Each process can have some threads. Process is nothing but, what you have to understand is, process have some memory, it has separate memory and also separate resources it has. Okay, separate memory and a separate resources. Each process is nothing but, suppose you are opening the Chrome, VS Code, like that, several things you are opening. Chrome is one process, VS Code is one process, like that. Each has a separate memory and a separate resources. Each process, what we call as each event has separate memory and resources. Okay, it is a process. And what is a thread? Thread is nothing but it is the smallest execution unit in a process. It is smallest execution unit in a process. Smallest execution unit in a process. And what is a task? Task is the thread which will be perform some activity. You are creating a thread, what will be the activity will be performed? It is a task. Task is a thread activity. Simply comparing with the real world analogy, suppose you are analyzing one restaurant, okay? Restaurants are there. Okay, restaurant 1, restaurant 2, like that. Everything has a different land occupation and a different manpower, right? Suppose take the restaurant as a process. Take restaurant as process for a while, and thread is like a chef is one thread, and bearer, okay, bearer is one thread. Suppose we have a watchman, right? Watchman is one thread. Suppose tasks are orders, okay, taking an order of order biryani, okay, order one task, taking the order, and open the gate. Who can open the gate? Watchman can open the gate. Who can take the orders? Bearer can take the order. Chef what can do? Prepare the food, right? Prepare the food. So if you understand that it is a process, means it is an environment. It is one environment. This environment can be equally shared by, equally not, the same memory or the same resources was shared by your chef, bearer and watchman, right? Both are, all are related to the same restaurant process only, right? So when you are creating a multiple threads, suppose chef is one thread, bearer is one thread, watchman is that. Chef cannot depend on a bearer, watchman cannot depend on a bearer. Each are independent, right? That is a multi-threading. That means all the works can be done parallelly. Suppose chef preparing the food, bearer continuously taking the orders, and also watchman who, when the people can come, he can open the door, he or she can open the door, right? That means every task will be isolated and concurrently working, right? Concurrently working at a same time they are working. It is a multi-threading. It is a thread. Simply one task you have to be done. Suppose prepare the food. Who can prepare the food? Chef. It is a task. This task will be done by a thread. It is a thread. Simply, it is a thread, and where it can be do, they can be doing a one environment. It is a one process. Okay, and multi-threading is you are creating a multiple number of threads. That means multiple tasks you have to be done in a single time. In a single time. Suppose in a 1 millisecond of time. Suppose at the time of now 10:32, right? At a 10:32 moment of time, chef also working, bearer also working, watchman also working. Watchman also working. All can be work parallelly, but doing the separate tasks. This is multi-threading. Multi-threading is simply multiple threads execute concurrently at a moment. It is a multi-threading. Okay. Now I hope it is understand what is the process, thread and the task. Okay. Now we are discussing a threads. Okay. Okay. Because the process is nothing but a memory which is you are performing the threads. So we have to focus on threads. Fine. This is the thread introduction. Thread is nothing but it is the smallest execution unit in a process. Smallest execution unit in a process. The same way, what the way we can multi-threading? Multi-threading means multi-threading is different, multiple threads is different. Okay. Multi-threading means concurrently it has to be work. Multiple thread means if it contains the threads, one after one it will be work. Normally, I can show the normal programming and the multi-threading programming. You can understand the difference between them. Multi-threading is multiple threads work concurrently at a moment. At a moment. Okay, at a single moment, concurrently or the parallelly, both will be the same, right? Fine. Now first we can see the normal programming, then we can see the multi-thread programming. Okay, first that we have to know how can we create a thread. Okay, how can we create a thread? Ways of creating the thread. I think there are the almost 6 ways are there. Ways of creating thread. The main we are discussing are 3 ways of creating thread. One was using a thread class. Using thread class. Using thread class. And another thing using a runnable interface. Using runnable interface. And another thing using lambda functions. Lambda functions or methods. Lambda functions or methods. Okay. In a 3 ways we are discussing these 3 ways, and also we can create by using a callable, and also we can creating using the executable one thing, and we can create by using a thread pool. Another 3 are there, but these are the thing we have to be doing. Why? Because we are at the learning stage. So these 3 are the enough. Interface, using runnable interface. Fine. Before discussing this thread, first we can analyze the normal programming. Suppose it is a day 17. New Java package. I can create a day 17. Okay. In this I can create a class. Suppose normal execution. Normal execution. Normal execution. Okay. In this I can create a main method. Why? Because I have to be run, right? So main method. For a while I can create a method here, void method 1 of, or else method 1 of sysout of method 1, sysout of method 1. Fine. In the same way I can create another method, void method 2 of sysout method 2. Okay, fine. Fine. Suppose you want to call the method, how can you call? First you have to create your class, right? Suppose n1 equals to new normal execution, and n1 dot method 1 and n2 dot n1 dot method 2. Now tell me, if I run this, what will be my output? First it will be print this method 1, that means it will execute first method 1 and after it will execute method 2. It is not a multi-threading, it is a single thread. It is a single thread. Normally everything is a thread. Suppose it has to be run a program, it has to be one thread. This is one task, right? So this task can be done through the thread. So what is the thread here is main. Main is the one thread. Main is one thread. Your main method was running. So, but how it will be run is, first it will be execute method 1 and after it will be execute method 2. Both are not doing concurrently. One after one it will be running. We are calling it as a normal programming or synchronized program. If you are dealing with the JavaScript, there are the 2 programmings are there, synchronized and non-asynchronized. Synchronized is nothing but you have to be wait for the one task has to be completed, then only you have to be task, and then only you have to be start another task. Now, if after completion of the method 1 only, it will be print or it will be execute this method 2. If it will not execute this method 1, then it will not execute that method 2 also. If any error will be occur, it will be failed to complete this task, then method 2 task also not executed, right? Now, why multi-threading is preferable in a normal real world project is, suppose if you are analyzing a Swiggy order in a Swiggy order, parallelly your there are the lots of tasks will be doing concurrently. Suppose you can find the distance of the delivery man from you, right, by the map, and you can check the status of the order. Status of order handled by one thread, and map functioning will be handled by one thread. And also the same in a same order it will be tracking by the restaurant also, right? So it is another thread. So multitask you have to be done by using that multithread. Suppose you have to be not doing that multithreading there, first you have to be wait for the completion of the one task only, you have to be done. For a while, suppose first you can place a cash on delivery or the cash on delivery based, later you can pay, right? This will be updated. That means that the payment will be maintained by one thread. It will be not depends on the another thread functionality. Every functioning in a real world projects will be performed on multi-threading. It's not on the Java, it will be depends on the programming language. Suppose if you are dealing with the front end part of the JavaScript or the React, they have the concept of asynchronized and the synchronized. It depends on the programming language, but the concept is the same. When you are dealing with the backend related to the Java, the multi-threading you can do like this the way. Okay, it is a normal programming. Then what will be the multi-threading programming is, for that you have to be create a thread for the every task, like this method. What is the method you have? You have to be create a thread. You have to be create for the thread for the every task. How can you do that is, my class is threads intro. Okay, ways of creating a thread. We can see the ways of creating a thread and all the things. Okay, I can have a main method. Okay, fine. Suppose I have one sysout of hello. Okay, before also I am telling that main is a one thread. Main is one thread. How can I say that main is one thread? Is sysout thread dot count. Thread is a class. Thread is a thread dot active count. Okay, thread is a class. In this thread class we have a method of active count. By using this we can know how many are the active threads we have. Here we have the only one active thread, that is the main. If I run this, you can observe. Thread count is 1. What is the thread is? Main is that thread. Main function will be, that means main thread task will be vanishes when it will execute this statement also. But this is the statement, that means main method not completed yet, so only one active thread we have, that is the main. Main is also one thread. Okay, suppose I can create a one thread. The thread is, suppose normally how can you create a thread is, first by using one way of the thread creation is using a thread class. Okay, thread is a predefined class. What I am here using, it is a one predefined class. So you can use, how can you use the thread class methods? Simply by using the inheritance. Simply by using the concept of inheritance. Suppose I can create a thread one as a method, class thread one. Extends, right? Thread is a class, right? So you have to be use a thread. Fine. And what the thing you have to be perform in a thread, you have to be write under the run method. Run method contains in the thread class. Thread implements by runnable interface. Okay, runnable interface. By using this runnable also we can create. By using this runnable also we can create a thread class. But you have to be understand that thread class. Thread class contains the run method. Okay, suppose I think interface contains the run method. If you see, Control F. if you see public abstract void of run method, our interfaces only contains the abstract methods, right? So run is one abstract method. This implementation right in the inherited class, that means child class. Child class is your thread class, right? So control F and I will check for the run. Run. 4, right? This is the run method. This is the run method. This run method you have to be override and write your own implementation. Only run method in a thread, run method only it has to be executed, not a set. And another method is there. Start. Remember this thing, run method one thing and start. This is the start method. What is the purpose of the start method is, start method can be start your thread. Run method can run your thread. Start method only can start your thread. Okay, fine. You can understand by the programming, you can understand. But you have to remember the terms runnable. Runnable is a interface. That interface contains one method, that is a run method. Okay, that functionality can be right in the child class of thread, and thread contains the two methods. One is run, which is inherited from the runnable interface, and one method start. Run method helps to run your task what you have to be performed by using the thread, and start is to start your thread. Start method helps to start the thread. Okay, these are the two things you have to be remember. Fine. Thread intro. Here I can create a one class, right? Thread 1 is my one class. Fine. In this task I can perform public void. Must you have to use at override annotation. Why? Because must not. Better to use. Why? Because suppose at override. Suppose if I mention here as a capital R instead of a small r, then it will throws the error to me. Why? Because it will throws an error to me. Is you are overriding a method of the run, so you have to be use small r. Small r is the, so must you have to. It is better you can use the at override annotation. It will be throws the error when you are using the different names. Okay, suppose here I can use the run method. Here I can print for int I equals to 0. I can print the 1 to 10 100 numbers. Okay, 1 to 100 numbers. I plus plus. Fine. And sys out of thread 1. Okay, thread 1 plus thread 1 plus I. Okay, thread 1 plus I. Fine. The same way, this is one thread. This is simply one thread. How can you run your thread is, fine. This is a thread, right? Normally it is a class. This class is inherited from the thread class, so it will become a thread. Then how can you create the thread object? You have to be run, right? Thread 1 equals to create an object for the class. T1 equals to new thread 1 of, right? Next T1 dot start. You can't directly call that run method. At final your run method only executes your task, but you can't directly able to call that run method. Okay, suppose normally your run method only can run your task. Suppose it has that, right? If you observe, this is my task, printing 1 to 100 numbers, but this task can contained by run method, but you can't able to directly call this method. That is the third. How can you call this method is by using the start method. So T1 dot start, and here you can print sysout of thread dot active count. Now you can check the thread dot active count. How many active threads you have? Thread dot active count. Okay, thread dot active count. If you can run the Java, right? But you can observe it will be print 1 to 100, right? But here it will be print 2. What it is? Thread count. Thread count is 2. Why? Because main is one thread and T1 is another thread. So it will be print count of 2. But if you observe, it will works concurrently. 2 threads, main thread and T1 thread works concurrently. Main thread and T1 thread works concurrently. How can I say that it will work concurrently? Because T1 dot start also running, but active count print first before the T1 dot start. Both are independent. So I can easily tell that. In a similar way, I can create another thread. Then you can easily understand, right? Maybe the same way I can create another thread of class thread2. Okay, extends thread. The same way. How can you create? Suppose in a class you can create a different variables and the different methods, right? You can create it, but that methods and the variables you can call by using this run method. Okay. Suppose here I can create one method. That method can be called by using this run method. Okay. I'll show that here. Suppose here I can create one method of void. Suppose print alphabets. Print alphabets is the method. And I can include one override method. What is that? At override public void run. Okay, this method I can call from here. This method I can call from the run method. Before I am running that task, but your class can contain the different methods and all the things, right? So how can you do that? For that, print alphabets. In this, suppose I want to print the alphabets. Okay, I want to print the alphabets. Then int alphabets can be start from the 65, right? So 65 I less than or equals to 95 I plus plus. Okay, what happened? I plus plus. Then sysout of character colon plus. Here you have to be print, right? How can you print the character? Using that typecast. Character of I. Char of I. Okay. Then it will be get. But what you have to do here? Create a thread. Thread T2 equals to new thread 2, right? Sorry. Thread 2. Thread 2 T2 equals to new thread of T2. Then you can write T2 dot start. Okay. Suppose before thread start. Okay, before threads start. Before thread start, what is the thread active count? Here I can use after thread start. Okay, Now I can run that Java. What it do? Okay, please enter. Fine. Yeah. Before thread start, active count of the thread is 1. Why? Because active count before the thread start is only the main thread. So count is 1. So after starting of the threads, your count becomes 3. Why? Because you have the 2 threads. You are creating the 2 threads, so it will become 3. Right? Thread 0. It will be the thread 1. It will be the character. That means it will be thread 2 output. Both are doing concurrent operations. If you observe, right? Both are doing the concurrent operations. Fine? Clear? It is the multithreading simply. You have to do some tasks concurrently. This is the one way of creating the threads. But you have to run your threads. Must you have to use the start method. There is no other option to use. Okay, only by using the start method only you can run it. Okay, this is one method of one way of creating the threads by using by using the thread class. Okay, now I can show you by using runnable. Okay, why? Because thread is also inherited from the runnable, right? So I can implement by using the runnable. So runnable is an interface, right? So for inheritance, what you have to use? Implements. So by this you can tell one thing, right? What it is? The better approach is you can go with the runnable. Why? Because you can use the multiple inheritance here, right? So you can better go with the runnable. In the projects also they can prefer with the runnable or the lambdas. Okay, runnable. By using that runnable you can go. Okay, runnable. It is a void run method. You can do it, and here it also. Okay, for a while it is normally like that. Okay. Then for the runnable threads, for the runnable way of thread creation, this is the not process. You have to be creating the threads. Okay, it is not the process of creating the threads in that way. Why? Because now your thread 1 is not a thread, it is only one runnable child. Okay, so your thread 1 not contains that start method, so you can't able to do that start. Then how can you write is, suppose control Z. If you observe here, it will throw an error here. Why? Because your thread 1 not contains that start method. Okay, your thread 1 not contains that start method. In before it will contains. Why? Because you are inherited from the thread class. So thread class contains that start method. So your thread 1 also contains that start method. Your parent contains the something, then you also contain the something, right? But your runnable is the parent here. For the thread 1, runnable is the parent. Runnable interface not contains that start method. So your thread 1 also not contains that start method. That is the issue. So how can you create the thread? Now it is not a thread. Okay, now it is not a thread, just one class. Then you have to make that class into a thread. How can you make that? Is simply use the thread class. Okay, you can use the thread class normally like a T1, new thread of, simply do a thing, call the object new, my name is thread 1, right? So I can use the thread 1.